Our next speaker is Kazim Adepoju from the School of Statistics. And his talk will be entitled An Improved Generalized Probability Distribution for Estimation of Income-Related Measures of Inequality. Please welcome Kazim.
Thank you. Thank you, everyone. I first want to appreciate the organizer of the workshop for the opportunity. Just like what I used to ask my student, is there anyone here struggling with the way I talk? My accent, is there anyone? Oh, thank you. Okay, so this is one of the research that I've been working on. The topic is very broad, but because of the limited time I got, I'm just going to focus on minimum wage. Okay, so this is just the situation. We live in a stochastic environment, and we live in a probability space. Whenever we want to define events, we use random variable. Minimum wage is a random variable, and we can only have a very reasonable inference if we know the right probability distribution for that. In statistical literature, the log-normal distribution. Sorry, okay.
Oh, and then I think we can use the buttons now.
Oh, okay.
Can you go back to the arrow keys?
Okay.
Should get you. Oh yeah, there you go.
Oh no. Okay. So the log-normal distribution is normally used for this as distribution for income. But log-normal distribution is not appropriate because of the fact that it assumes what I call a multiplicative growth. It assigns large probability for small values and skew towards large values, I mean the billionaires. And because of that, it's not a good distribution for income. And it is not also a good distribution for minimum wage because of these four reasons. Number one, the log-normal distribution I'm talking about, equation 1, that is log-normal distribution I'm talking about. It does not have what I call lower bound. And of course, minimum wage has a lower bound. The lower bound of minimum wage is the minimum wage itself. And that distribution does not incorporate what I call legislative action. What I want to believe, changes in minimum wage is caused, by legislative action. I want to believe that if the majority of, in the two chambers, if the party of the president has majority by now, I know they would have passed $15 minimum wage. So now we needed a distribution, that we incorporate the lower bound that I talk about and the legislative action. And that was why I used the principle of order statistics. I may not be able to show all of that because of my time. Equation 3 here is the proposed distribution I call exponentiated log-normal distribution. In this exponentiated log-normal distribution, of course, we've incorporated what is missing. Of course, I have some derivation there for lowest curve and the like, but I quickly want to go into analysis. Here I'm using minimum wage in the United States between 1968 and 2020. The table 1 is the descriptive statistics. If you look at table 2, I'm trying to compare the performance of the exponentiated log-normal with the conventional log-normal distribution to fit minimum wage. And based on the Moodle selection criteria, the AIC and the BIC, of course, the proposed distribution outperform the conventional one. Of course, this is a typical, if you take a look at, because for federal minimum wage, the log-normal distribution, look at the shape. But if you want to talk about the histogram, the density of the data itself is what you can see at the other side. Of course, there is no, they don't agree. And this is also nullified. The idea of using log-normal distribution is finally, I'm actually going to say, if we're seeking to figure out the probability distribution for minimum wage, then I'm actually suggesting that the proposed exponentiated log-normal distribution should be used because it takes into consideration the lower bound and the legislative action. Thanks once again for the opportunity.